In this example, we're going to differentiate two functions where there are inverse trig functions. Here I've got an inverse sine. Remember, arctan is the same thing as inverse tangent. So starting with A, we can rewrite this function as a negative exponent. So we could rewrite this as inverse sine to the negative first, since it's on the bottom. And then we would use a chain rule to find this derivative. The other way to do it would be to just see this as a quotient and use quotient rule to find the derivative. But using chain rule here, we would bring the negative 1 in front, and then we would take 1 away from the exponent. So that'd be the derivative of the outside, and then times derivative of the inside. Then we would look at our inverse trig function derivatives, and inverse sine, the derivative of that is 1 over rad 1 minus x squared. And then we just want to simplify it. So that is my derivative so far. We can move negative exponents to the bottom. So that would leave this negative 1 on top. And then on the bottom, then I would have inverse sine squared. And then I would have radical 1 minus x squared. So that would be my derivative for A. For B, we've got a product. We've got x times arc tangent radical x. And inside of this product, we're going to have a chain, because that's not just an x, it's a radical x. So let's start the product rule. I've got first, leave the first, derivative of the second. Remember, this is going to be a chain rule. So first we're going to do derivative of inverse tangent. And if we look at our derivative for inverse tangent, it's 1 over 1 plus x squared. 1 over 1 plus x squared. But the x in this case is a radical x. So it's radical x squared. And then, so that's derivative of the arctan part. We still have to do derivative of the square root x part. So then we also multiply by, so remember, square root x is the same thing as x to the 1/2. So the derivative would be 1/2 x to the negative 1/2. So remember, we're doing product rule. So I left the first and did derivative of the second. These two things are derivative of the arctan radical x. Plus derivative of the first, derivative of x is 1, and then leave the second alone. And then we just want to simplify this. So let's start over here with this mess. I've got x over this, and the square root and the square cancel. And then here I've got a 1/2, so I could put that in front. And I've got then a radical x on the bottom, because the 1/2 means square root, and the negative puts it on the bottom. And then one more thing to clean it up is to get rid of your radical on the bottom. So if you put a radical on top and on bottom, that would give me x rad x over 2 1 plus x x, because those would make x. And then lastly, we can cancel that extra x that we have. So my derivative is square root x of 2 times 1 plus x. You could distribute that if you want. Plus arctan rad x.